Hello everybody. Mathematics. As a subject, many young students have certain viewpoints. For most of them, it is fiery and scary. For some, it is boring and disinteresting. And for some, it is challenging and slogging. The truth is, mathematics is like swimming, a subject with which you all will be uncomfortable in the beginning, but after being with it for a while and understanding the basic concepts of mathematics, you will find it just the opposite. You will like it, you will start loving it, and ultimately you will start using its application in your day-to-day life as well. So here I am, Pankaj sir, to take you for a tour of mathematics in a way that the concept clarity will always be there, as well as there will be a very enjoyable journey of mathematics. So come along with me and let me take you to the very first concept of mathematics, which is called as the story of numbers. So here you can see on the screen, I am here with you with a story of numbers. Now these are the very basic things that any student should approach mathematics with. Okay, basic mathematics. You must have heard about parents, always uh, asking each other, like my student, my child, is very poor in his basic. Okay, so basic mathematics is generally something which has to be taught in a very nice, easy way. Is the building stone of your mathematics as a career or as a subject which has to be understood fully. Okay, so basic mathematics with the concept clarity is something that I am going to be concentrating on. And my very first topic is for these primary students, okay, very young people who are just entering into the world of mathematics. And why I call it, it is similar to swimming, because one can remember, if you go for swimming, initially you are always very uncomfortable with the water. You try to struggle, you try to uh, you try to see everything that you can do to float on the water, but the water doesn't allow you to do that. What happens is, after a lot of try, after a lot of understanding, once you give up, you say, okay, water, I'm not going to fight with you. I don't want to conquer you. On the contrary, I want to be friends with you. I want to be interested in you. I want to like you. And then the water will teach you how to float. This is what I have personally experienced while learning swimming. And this is what makes me compare it with mathematics as well. Okay. So let us start with the very basic topic called numbers. So the very first number invented by humans. Now in this lesson of mine, there must be many hypothetical things that I'll be talking about, but you take it as a part of a story so that you understand comfortably and you enjoy mathematics with me. Okay. So let me tell you, when we talk about mathematics, initially in the lower classes, we are taught not mathematics exactly, but we are taught arithmetic. Arithmetic is a branch of mathematics which deals with numbers. Okay. Later on, algebra and geometry, which are other two factions of mathematics, will come into the topic of mathematics as well. So let us start with arithmetic, that is numbers. If you think about it, the very first number that must have invented by humans should be what? It was a 0. Okay. And what is the meaning of that number 0? The meaning is nothing or empty. When you want to say that I don't have anything, okay, or I don't have, I'm empty pocket, okay, that means you are representing it by a number called 0. Next, what happened is there was an invention of a single digit counting number. Now, this counting number became important because the invention of counting number must have become important because in those days, there was something which was called as barter system. So if you wanted, say, rice from somebody, then you have to give them something else in exchange. Okay. For example, if you want rice from somebody, then you'll have to give, say, uh, uh, a piece of coal, which is used for burning and all that, that to the other person. Okay. So instead of coal, you will be getting uh, what you want. Okay. So this is something called barter system. So in barter system, counting was very essential. So first they thought that let us invent some few single digit numbers, and they invented 1 to 9, that is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these were the 9 figures written in this way, and this represents the 9 single digit numbers. Okay. Along with 0, it is going to make 10 single digits. Okay. So the total number invented by now is 10. By now means I am taking you to that period. Okay. So be with me in that period only. So total numbers invented now is 10. Okay. And this 10 single digit number can be called as 10 digits. Okay. So which are the 10 digits that were invented long back? 0, and then 1, 2, 3, 4, 5, 6, 7, 8 and 9. So in totality, how many digits are there? There are 10 digits. 0, and then from 1 to 9, there are another 9 digits. So total, how many digits are there? 10. Many a times when students are asked how many digits are there in mathematics, okay, they say 9 because they don't consider 0 as a digit. They just count 1 to 9. Okay. So in totality, there are 10 digits, including 0. Okay. Now, from these 10 digits, further numbers were made. Suppose if somebody wants to say, I have nothing with me, he will say, I have 0. If somebody wants to say, I have 2 piece of, wood with me, okay, he will say, he will write 2. If somebody says, I have 9 piece of, chicks with me, okay, that means he will write this 9. But suppose he wants to write more than that, okay, suppose he wants to go into 2 digit, then he will use this single digits as 1 and 0 and make it 10. Then 1 and 1 will make it 11. Then 1 and 2, 12. 1 and 3, 13. 1 and 4, 14. So that way, double digits number were also invented, and up to 99, double digits number were recognized. Okay. After double digit number, they wanted more numbers to be invented. So they ventured into writing it 100 using the using the digit 1 and 0 twice. So 100 was representing 100. So 100 is the first 3-digit number. 100 is the first 3-digit number. Okay. Then 101, 102, 103. That way all the 3-digit numbers started. So this way you can make numbers up to countless values. Okay, that is known as infinity. So the digits were used to make numbers as big as infinity. Okay, infinity is a concept which represents a very, very, very big number. It is not actually a number. Okay, but it's a very big, very huge, endless number. It is not a number. Okay, later on they thought about putting a negative sign in front of these digits, that is 1 2 3 4 5 6 7 8 9 10 11 etc. Okay, so all the numbers that were formed, if you put a negative in front of that, that will be called as a negative counting number. So these were also invented, negative counting numbers. Now you may think why negative counting numbers must have been necessary, or what must have been the need of the hour at that time. The reason is many a times you have to tell something as loss, or you have to tell something as decrease, or you have to tell something as you know lower down. So all these things can be represented by a negative number. If I want to say that the temperature of a place was decreased from 0 degree to 5 degree, 0 degree by 5 degree. Okay, so from 0 the temperature came down by 5 degree. What will be that temperature? So there should be some representative number for that. So that number can be represented as negative 5, okay, or minus 5. So this is where the negative numbers, the negative counting numbers became very much essential. Remember, 0 has no negative or a positive. 0 is a number, or 0 is a digit which cannot be assigned any positive or a negative sign. Okay. Now, n plus represents positive counting numbers. These are also called as positive natural numbers, right? N minus is representing negative counting numbers. Many times it is also called as negative natural numbers or negative counting numbers. C or Z is the integers, which is a union of positive natural numbers, negative natural numbers, and 0. So when you combine all the three, the positive natural numbers, the negative natural numbers, and 0, you get a set of integers, which is represented by a Z. W, it's a whole numbers, okay, and it is a union of 0 and the positive natural numbers. Now, what is a number line representing integers? So number line representing integers is a straight line, imaginary straight line. Okay. And in the center of that line, you have a 0. And that at equal distance, you have points which are representing 1, 2, 3, 4, 5, 6, etc. on the right. This is the right side of the number line. Okay. And on the left, at the same equal distance, you have to mark -1, -2, -3 up to minus infinity. This is to the left of the number line. Okay. So to the right of the number line, you will have all positive natural numbers, and to the left, you will have negative natural numbers. And along with this positive natural numbers, negative natural numbers, and the 0 at the center, the whole line is represented by these different points, which is known as a number line of integers, because integers is nothing but a union of positive natural numbers, negative natural numbers, and the 0. Now if you want to write in the form of set, n is representing, capital N is representing a set, so you can write as n equal to curly bracket 1 comma 2 comma 3 comma 4 comma 5 comma 6. It will go on up to infinity. Now on the right hand side, there will be a positive infinity. Okay. N plus is the same thing as this only. 1, 2, 3, 4, 5, 6, because these are positive natural numbers. Negative natural numbers will be starting from the left of 0 on the number line, starting from -1, then -2, -3, -4, and it will go on to the left of the number line. And the last number, you cannot say the last number, but the very extreme left, you will have a negative infinity. Again, I am telling you, positive infinity and negative infinity are not any fixed numbers. Okay, they are just a concept, they are just an idea. It's a very, very huge positive number, that is positive infinity. And negative infinity is a very, very, very less or a small negative number, which is represented by negative infinity. Whole numbers. Whole numbers is a set of a 0 and then positive counting numbers. So 1, 2, 3, 4, 5, 6, etc. So natural numbers, positive natural numbers, including a 0, is nothing but a set of whole numbers. And if you want to write a set of integers, then you'll have to represent it by a z, and it is equal to curly bracket. There will be 0 in the center. On the right of 0, you have to write all positive natural numbers 1, 2, 3, 4, etc. up to positive infinity. And on the left, you will have to write -1, -2, -3 up to minus infinity. So this is representing your set of integers. So, in basic mathematics, you must know that the number story starts with 0 and then a few single digit numbers from 1 to 9. And using this 0 and the single digit numbers, you can form so many various numbers, right? Then these numbers in totality can be classified into something called positive natural numbers, negative natural numbers, whole numbers, and integers. Okay? One more thing you will notice about these numbers. Number one is this natural number is a subset of whole number. What I mean to say is all the natural numbers can be kept in a box which is containing a whole number, or you can say that natural number is a subset of whole numbers. Okay, so all natural numbers are whole numbers. Okay, all natural numbers are whole numbers, but all whole numbers are not natural numbers. So which is the whole number which is not a natural number? Of course your answer will be 0. 0 is a whole number which is not a natural number. Same way, whole number is a subset of integers. Okay, so whole numbers is a subset of integers. The entire whole number will be coming in the set of integers, right? But the meaning of this is there are certain integers which are not whole numbers. Now, if somebody asks you which are the integers which are not whole numbers, of course you can tell them -1, -2. These are the integers which are not whole numbers, right? Because whole numbers is only 0 and the positive natural numbers. -1, -2 are all negative natural numbers. Okay. Second point you have to remember is the union. This symbol represents union. Okay. So positive natural numbers, negative natural numbers, and 0. The union of these three, the positive natural numbers, the negative natural numbers, and the 0. The union of these three makes up the integer set. Okay. So what is integers? Integers is the union of 0, positive natural number, and negative natural numbers. Fine. What is whole numbers? Whole number is a union of a 0 and the positive natural number. Whole number will not consist of negative natural numbers. One more important thing, the fourth point, very important. Don't think that positive natural number plus negative natural number is together going to make natural numbers. No, it is not like that. The thing is, natural numbers are numbers, okay, which are also known as counting numbers, and they can be classified into two categories as positive counting numbers, that is n plus, and negative counting numbers, that is n minus. Positive natural numbers can be treated as natural numbers only, but negative natural numbers are not natural numbers. If somebody tells you that -2 is a natural number, true or false, your answer should be false. -2 is not a natural number because natural number starts from 1, 2, 3, 4, 5 and it goes up to positive infinity. -1, -2 doesn't come in this set of natural numbers. And negative natural number consists of -1, -2, -3, etc. Okay, so minus negative natural numbers and natural numbers both are not the same, right? Let us come to the next concept: addition and subtraction of natural numbers and whole numbers. Now let us see what is the meaning of addition and subtraction of natural numbers. Now suppose you take a natural number, say 1, another natural number, say 5, and you add them. Okay, 1 plus 5, you will get a 6. Now is 6 a natural number? It is a natural number. So when you add two natural numbers, it results in a natural number. 6 is also a natural number, right? Let us see one more. 100 and 200, both are natural numbers? Yes. When you add them, what you get? You get 300. Is it a natural number? Yes, it is a natural number. So whenever you add two natural numbers and the result is also a natural number, then we say that natural numbers is a closure property of addition, or you can say that addition is a closure property of natural numbers. What do you say? Addition is a closure property of natural number. Can you see this statement? This statement will come from this. Now same way, let us see whether subtraction is a closure property of natural number. So what I'll do, I'll take two natural numbers. Let me take 1 and 5 and let me subtract. So 1 minus 5 is -4. Okay. I can see that after subtracting 5 from 1, which are both natural numbers, I am getting a result as -4, which is not a natural number. I told you here, natural numbers and negative natural numbers are not the same. -4 is not a natural number. So what we can say about the subtraction, subtraction is not a closure property of natural number. Okay. So I think you must have understood what is the meaning of closure property by now. So if you take two natural numbers, if you add them and the result is also a natural number, then you say that addition is a closure property of natural number. If you take two natural numbers, if you subtract them and if you get a if you get a natural number, then you can say that subtraction is also a closure property of natural number. But that doesn't happen. When you subtract two natural numbers, you get a number which is not natural number. So we say that it is not a closure property. Subtraction is not a closure property of natural number. Same way you can check for whole numbers. Now let us check for whole numbers with the example of 0 and 5. 0 plus 5 is equal to 5. 100 plus 0 is equal to 100. So when I add these two whole numbers 0 and 5, the resultant is also a whole number. Okay, in both these examples you can see that. So we can very nicely say that the addition is a closure property of whole number as well. So not only natural numbers, whole numbers also addition behaves as a closure property. Addition is a closure property in both natural numbers and whole numbers. But in the case of subtraction, let us see. 0 minus 5 will give you -5. Now 0 and 5 both are whole numbers. When you subtract them, you get a -5. But -5 isn't a whole number. So what you will say for subtraction? Subtraction is not a closure property of whole numbers. So for both natural number and whole numbers, addition is a closure property. Subtraction is not a closure property. Is that clear? So this concept has to be very clear. Next, let us try natural number 1 plus 5 and let us swipe them. Okay, 1 plus 5, you swipe them, make it 5 plus 1. Okay, now you should see that 1 plus 5 is 6 and 5 plus 1 is also 6. So when you swipe the position of the two natural numbers, still the addition product or the addition result remains the same. 1 plus 5 is also 6, 5 plus 1 is also 6. So here we say that n plus 1, the two natural numbers ka sum, is same as n2 plus n1. When you swipe and add, the same thing you will get. Okay. So whether you add n1 plus n2 or you add n2 plus n1, the result will be same. Such a property is known as commutative property for addition, because this is what you see on addition. So let us check for natural numbers. 1 plus 5 is equal to 5 plus 1. It is a yes. It is. Let us take another example. 100 and 200. Is 100 plus 200 same as 200 plus 100? Yes. Both will give me the answer as 300. So this is telling me that addition is a commutative property for natural numbers. Now we have just checked for natural numbers right now. Okay. So addition is a commutative property for natural numbers. Now let us check for whole numbers. Suppose if I take 0 and 5, the two whole numbers. So 0 plus 5, 5 plus 0. Both will be same. Yes, 5 plus 0 will be 5 and 0 plus 5 will also be 5. Now 2 plus 5 and 5 plus 2. Is it the same? Yes, it is same. 2 plus 5 is 7, 5 plus 2 is also 7. These are whole numbers, right? So addition is commutative for both natural numbers as well as whole numbers, right? So for whole number also, addition is commutative. Okay. Now let us check subtraction for natural numbers. If I take 1 minus 5, is it the same as 5 minus 1 after swiping the position of 1 and 5? No. 1 minus 5 is minus 4. 5 minus 1 is 4. They are not the same. They are not equal. So what I will say is n1 minus n2 is not equal to n2 minus n1. Okay. Another example is 25 minus 20, which is pi, is not equal to 20 minus 25. In fact, 20 minus 25 is minus 5. 5 and minus 5 are not the same. So you see here that after swiping the uh, natural numbers, okay, the subtraction results are totally different. So we say that subtraction is not commutative for natural numbers And same thing will happen for whole numbers also. For whole numbers also, subtraction is not commutative. So we come to a big conclusion that the subtraction is not commutative for both natural number and whole number, and addition is commutative for both natural number and whole numbers, isn't it? Now, a very interesting question arises. What about multiplication of natural number and whole numbers? Okay. Is it a closure property? Is it commutative? Let us check it. So now that you have understood what is closure property, what is commutative property, you can apply that for for this multiplication. So let us try natural numbers. Example, let us take two natural numbers 1 and 5. Okay, these are both natural numbers. Let us multiply them. 1 into 5 will be 5. Okay. Now, when you multiply these two natural numbers, the result is also a natural number. Let us take another example. 25 and 5. Both are natural numbers. When you multiply them, you get 125, which is also a natural number. So, whenever you multiply two natural numbers, so n1, a natural number multiplied by any other natural number, will always give you a natural number. Third one will always be a natural number. Okay. So, this tells you that multiplication is a closure property. So, multiplication is a closure property of natural numbers, right? Now let us check the commutative property of multiplication. Suppose you take, or let us try this closure property of whole numbers. So let us take whole numbers 0 and 5. 0 into 5 will be 0. Now 0 is a whole number, 5 is a whole number. When you multiply them out, you get a 0, which is also a whole number. Okay. So multiplication of a whole number with another whole number is also giving you a whole number. The third answer, the product will also be a whole number. Definitely 0 is a whole number. Here 5 and 5 are both whole numbers. So 25 is also a whole number. So, and whenever you multiply two whole numbers, you will always get the result as a whole number. So you can say that multiplication is a closure property for whole number as well. So the combined statement can be made as multiplication is a closure property for both natural numbers and whole numbers. Okay. Now combining this B and the A. Can you see? This is that A statement and you have the B statement over here. Okay. When you combine them, you can make this particular statement that I have written in this bracket over here. Okay. So combining A and B, we can write from A and B, we can conclude that addition, subtraction, and multiplication are closure properties for both natural number and whole number, right? Also, addition and multiplication are commutative for both natural and whole numbers. Okay. But only thing is not commutative is subtraction. Subtraction is not commutative for whole numbers. Is that clear? So this is the ultimate uh, thing that you can derive from the discussion that I have made so far with you. Okay. So now let us discuss the closure and commutative properties of integers. As I told you, integers is a combination of all positive natural numbers, negative natural numbers, and the zero. Okay. So when you think about integers, think that it can be anything from 1, 2, 3, 4, 5, 6 up to positive infinity, anything from -1, -2, -3, -4 up to minus infinity, and 0 as well. Okay, let me tell you what is not an integer. Any number between 2 and 3 will not be an integer. For example, 2.5, 2.3, 2.1, 2.8. These are not integers. Okay. Any number between 0 and 1 will not be integers. Okay. Say 0.1, 0.2, 0.5, 0.8, 0.88. All these are not integers. Okay. So now we will get an idea of what are integers. Integers are complete numbers. They will not be having any decimal form. Okay. Decimal numbers never come in integers, right? So let us try to discuss the closure and the commutative properties of Z. Now, Z is a set of integers and it is the sum of two integers. Now, Z, let us try to see this statement. Sum of two integers always results in an integer. You think of any two integer, okay? You just add them up. Let me think of a negative integer -5 and let me think of a positive integer, say 4. Okay. Now let me add this two, minus 5 and plus 4. Now if you know how to add them, you will come to know that the answer for this is minus 5 plus 4 is minus 1. And this minus 1 is an integer. Okay. So when you add two integers, you get a resultant integer only. Okay. And when you do the subtraction, suppose you take one integer as 0 and you subtract 5 from that. Okay. So this is subtraction of two integers. The answer will be what? Will be minus 5, which is also an integer. So when you subtract two integers, still you get the result as an integer only. So when you add or subtract two integers, you will always get a resulting integer only. That means the addition and subtraction are both closure property for Z. Z is what? Integers. Okay. Are you getting me? Fine. Now let us check for multiplication. So let us multiply two integers and let us see whether that results in an integer. Let us take minus 5 and plus 4. Let us multiply that. Okay. You will see that this answer will be plus into minus, minus 5 into 4, 20, and minus 20 is an integer. So when you multiply two integers, you will always get an integer. So you can say that multiplication is also a closure property for integers. Okay. What about division? Division can also be closure property except for one particular case, and that case is dividing by a zero. What happens when you divide any number, say any integer, when you divide by zero, this denominator, if you have a zero, in mathematics this is known as meaningless, or it is known as something called not defined, ND. Okay, it is known as meaningless or not defined. So dividing any number by zero or putting zero in the denominator means in mathematics, it means that it is meaningless, it is not defined. Okay. So when you divide any number by any integer by zero, okay, you will get a number which is meaningless, and meaningless doesn't mean integers. So there is one case after dividing, there is one case where you get a number, where you get a result which is not an integer, and this is this case. This is that case. Okay. When you divide 2 by 0, this 2 by 0 is not 0. Okay. It is not 0. 2 by 0 is not equal to 0. 2 by 0 is not equal to 2 also. Both these statements are wrong. 2 upon 0 is equal to not defined. This is the right statement. Okay. So division is not closure property of integers. This is very important. So multiplication is a closure property of integer, but this division, can you see this division? It is not a closure property of integer. Very important. Why? Because of this division by zero. When you divide by zero, any number when you divide by zero, it results in a meaningless number. Okay. So it is not closure property. So we can make the statement over here. Addition, subtraction and multiplication, okay, addition, subtraction and multiplication are closure property of integers, but division is not a closure property of integers. Okay. Now let us try to understand this. Z1 plus Z2 is equal to Z2 plus Z1. Is this always true? What I mean to say is Z1 and Z2 are two integers. So let us think of two integers, say minus 5 and say plus 4 or minus 4. Okay, these are two integers, minus 5 and minus 4. I am adding them. Now, is this the same as adding minus 4 plus minus 5? What I am doing here, I am swiping the position of these two. Okay. So minus 5 plus a minus 4 is minus 9. And minus 5, minus 4 plus minus 5 is also minus 9. So when you swipe the position, still the addition of two integers remains the same. That means we can say that addition is commutative property of integers. But what about subtraction? Now let us say minus 5 is an integer From this, you are subtracting 4. What will be the answer? Minus 5 minus 4 will be minus 9. Now swipe the position of these two. So 4 minus of minus 5. What will be the answer? It will be 4 plus 5. It will be plus 9. So after swiping the position, the subtraction result is different. Here you are getting the subtraction result as minus 9. Here you are getting as plus 9. So you will say that it is not commutative. So subtraction is not commutative for integers. So in this today's session, today I wanted just to make this integers concept, the concept of integers, to you students as clear as possible, because these are the things which once understood, now when I tell you to add, subtract, multiply or divide any two integers, you will understand the process of doing that, and you will not have to mug up the answers for that. Okay. And you don't have to remember any particular method of doing it. Okay, once you know these properties, you know what you are supposed to do. Okay, and this will be continued in the next class. So for today, that's all. See you in the next class of mine, where I'll be trying to teach you basic mathematics as a enjoyable subject. Okay, where concepts will be given the utmost importance. Thank you for being with me. Bye. Take care, all of you.